Chemical Equilibrium, Lesson 2, on 24th April 2019. So we are saying that when the products and the reactants of a reversible reaction are in a gaseous state, the equilibrium constant can be expressed in terms of partial pressures. For example, nitrogen plus hydrogen, you get ammonia. The equilibrium constant Kp will be equal to partial pressure of ammonia squared over partial pressure of nitrogen times partial pressure of hydrogen to power 3, where partial pressure of ammonia is equal to mole fraction of ammonia times total pressure of the system. P is the pressure of the system. This sign X ammonia means mole fraction of ammonia. Mole fraction of ammonia is equal to moles of ammonia over the total moles in the system. Example 1. Nitrogen reacts with hydrogen to form ammonia according to the following equation. Nitrogen plus hydrogen get ammonia gas. 1 mole of nitrogen was reacted with 3 moles of hydrogen at equilibrium at 50 atmospheres. 0.2 moles of nitrogen had reacted. Calculate Kp. First, you rewrite the equation. Nitrogen plus gas plus 3 hydrogen gas will give you 2 NH3 gas. You say that initially we have 1 mole, 3 mole at equilibrium. They have told us 0.2 moles of nitrogen had reacted. When 0.2 moles react, you remain with 0.8 moles. But 1 mole reacts with 3 moles. 0.2 moles of nitrogen will react with 0.2 times 3 moles of hydrogen, which is 0.6. So what is remaining here will be 3 minus 0.6. You will get 2.4 moles. Also, we are saying that when 1 mole react, 2 moles form. When 0.2 moles of nitrogen react, 0.4 moles of ammonia forms. So total moles at equilibrium will be equal to 0.8 plus 2.4 plus 0.4, which will be equal to 3.6. Then the partial pressure of ammonia will be equal to 0.4 over 3.6 times the total pressure of the system, which is 50. Then the partial pressure of nitrogen will be equal to 0.8 over 3.6 times 50, and partial pressure of hydrogen will be equal to 2.4 over 3.6 times 50, which is equal to 5.6. This one is equal to 11.1. Then this one is equal to 33.3. Remember that P total is equal to P NH2 plus PN2 plus PH2, which is equal to 50.0 atmospheres. Then Kp will be equal to 5.6 squared over 11.1 times 33.3 cubed, which will be equal to 0.0008 atmosphere per negative 2. Example 2. Nitrogen reacts with hydrogen according to the equation. Nitrogen plus hydrogen will give you ammonia. Write expression for equilibrium constant Kp in terms of partial pressures. Kp is equal to partial pressure of ammonia raised to power 2 over partial pressure of nitrogen times partial pressure of hydrogen raised to power 3. The units will be per atmosphere squared. 1 mole of nitrogen was reacted with 3 moles of hydrogen at 50 atmosphere. At equilibrium, 0.8 moles of ammonia was formed. Calculate Kp. First, we have to calculate the moles at equilibrium. Initially, 1 mole of nitrogen was reacted with 3 moles of hydrogen. There was no ammonia. At equilibrium, they told us 0.8 moles of ammonia formed. So we would find out how many moles of nitrogen reacted. We would say that 2 moles of ammonia requires 1 moles of nitrogen. Therefore, 0.8 will require 0.8 times 1 over 2, which is equal to 0.4. When 0.4 react, what remains will be 1 minus 0.4, which is equal to 0.6. Then we would also find the moles of hydrogen at equilibrium. 2 moles of ammonia requires 3 moles of hydrogen. If 0.8 formed, how many moles of hydrogen reacted? Will be 3 times 0.8 divided by 2, which would be equal to 1.2. When 1.2 react, what remains will be 3 minus 1.2, which is equal to 1.8. Total moles will be equal to 0.6 plus 1.8 plus 0.8, which is 3.2. Then partial pressure of nitrogen will be the moles of nitrogen over the 2 moles times the pressure of the system, which is 50, and it gave you 9.375. The partial pressure of hydrogen will be 28.125. The partial pressure of ammonia will be moles of ammonia over the total moles times the pressure, which is 12.5. Then the Kp is equal to partial pressure of ammonia squared over partial pressure of nitrogen times the partial pressure of hydrogen to power 3, and it will give you 0.00075 per atmosphere squared.
The Science Foundation College enamave ku Lwejjinja ng'oyingira kilomita emu. Somero lya Dene Boarding ery'abawala n'abalenzi. Ku O-level tusomesa arts ne sciences, ate A-level tusomesa sciences zokka. Omwana mulete ku The Science Foundation College. Ffe tusinga okusomesa sciences. Okumanya ebisingawo kuba ku 0753 827 09. The Science Foundation College, based on sciences and based for sciences.
Example 3. Nitrogen and hydrogen form ammonia according to the equation. Hydrogen plus nitrogen is equal to ammonia gas. At a certain temperature, the equilibrium constant for the reaction between the nitrogen and the hydrogen, Kp, was 4.82 times 10 to the power negative 5 per atmosphere squared. The partial pressures of nitrogen and hydrogen were 30 and 120 atmosphere respectively. 1. Write the expression for Kp. Kp is equal to partial pressure of ammonia raised to power 2 over partial pressure of nitrogen times the partial pressure of hydrogen to power 3. Then calculate the partial pressure of ammonia at equilibrium. We say that Kp, which is equal to 4.82 times 10 to the power negative 5 is equal to partial pressure of ammonia squared over partial pressure of nitrogen, which is 30, times the partial pressure of hydrogen, which is 120 to the power 3. It implies that partial pressure of ammonia is equal to root 4.82 times 10 to the power negative 5 times 30 times 120 to the power 3, which is equal to 50 atmospheres.
Kita Bbosa science, kwano kwa beti science, dafu ya Bbosa science, truth na beta, truth na omega, truth na alpha science.
Thank you very much. The next lesson is going to be factors that affect the value of Kc and Kp.